Welcome back. It's Sunday. I am going to start the assembly of the retro trip tester, this guy right here. So I have been pulling lots of parts out of the bin, and the first one I'm actually going to begin with is this batch. These are 470 ohm resistors. So first thing we're going to do is get them off the strip. Now I could pull them off the wires, but it really doesn't really matter. So for this thing, I have to take my glasses off for a little bit. There's 54 of these to do. Actually, let's turn the wire snippers around here. So these resistors come from basically, a feed machine. Lots and lots, 54 of them. Believe it or not, this one long strip isn't 54 of them. It's actually, I think, 49. I really lowered my 470 ohm resistor count in the bag. Or 48 maybe, because I'm counting in evens. So that's one side. I'm just going to move my glasses over there. So yeah, apparently, I don't know where I put them, but I thought I had a variety of crystals. Because this thing calls for a couple, and I don't seem to have them. So, and I don't have a Uline 2003A. It's a big Super Darlington pair thing, according to the docs. 16 pin, 2/8 on each side, dipsat package. So that I can't put in. So I can get I think I can get all the resistors in, the diodes in, and possibly, I think I have all the caps I need. And the relay and some stuff like that. The ZIF socket, I found it. It's right in front of my face. So there we go. Like so. Okay, so scoop those off the side here. So we have this guy here. Really? This is red and it's showing up orange in OBS. I wonder why. So what we have here is we have to right along here and light along here. There's all these 470 ohms. So first of all, we have to see if I get the whole. Hopefully this guy, when he did this, which he didn't do, so what I'm going to do, I'm going to mount this board in my holder so it's closer to me, and like so. I think I'm pushing the limits on this thing. It'll be pretty long. See? Long, long, long. Long, long. Now this side here, let's just see if we can balance the bar out a little bit. Yeah, I'm at the edge of the stand. So since we used, looks like number 3, we just have to bend a whole bunch of these now. This is what, and I better drop some of these on the floor. I could step on them and then that would hurt. Oh, you're thinking, oh, wait a minute, that's just resistors. Well, get one of these little legs poked into you. It's not nice. So what we're doing is this. One, two, three. Yeah, just past the edge. Now, of course, after doing all these, I find out that they're not 470 ohms. You know, Murphy's Law would step in and screw us around on that, right? So let's just put one of these across and just check. Yep, 470 ohms. It's always a good idea with the multimeter, just in case, just to double check your work. Well, it's pretty sure because the it begins with yellow, so yellow is 4. Resistor color code. Oops, that was wrong. I was on the wrong notch there for that one. Let's see what happens if I do one notch back. So they're graduated here, see? You know there's a machine that actually does this? It actually automatically does this. And then I have to do all the diodes. I don't think I'll get this whole thing done right now. I might get all the resistors in and then I'll take a break and then I'll have to do the thing. This is a bit hard on the back actually for me. Whoops. Speak of the devil. I threw resistors off the thing. Okay. Just an expression. Don't get all horny over it. Now I really threw one on the floor. And of course I can't see it. There it is. Wow. It is very hard to get off the carpet. There we go. Let's try not to do this again. I would just change the tilt of the table slightly. Okay. So apparently, true to statistical form in the United States, they had another big mass shooting in, where was that? Was it Pennsylvania or something like that? I can't remember. Shot up a restaurant or something like that. And they're still arguing down there over guns, man. I wonder whether people will finally wake up and realize that those things just are not needed. What you really need is resistors, capacitors, inductors, i.e., you need a project like this to keep your mind off the world. Okay, so it's one batch. So I have this tendency, I'm just going to take my glasses off to do this. I have this tendency to like to line up my resistors into the same orientation. Like so. And yellow down there. Like so. Whoops. Bent leg. Boy, it's starting to get hot around here. I guess I could say that June has arrived. Supposed to get some rain, I think, today. Kind of surprising. I was expecting the snowmelt to show up in the Bow River, but it didn't yet. The river's not really that high. They did all this work for flood control and nothing to show for it. No floods. Well, that's a good thing. We don't want a bunch of floods to ruin our day. Brown, 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 brown. Yep, okay. And seems to me this is all resistance diode pairs. Oh, yellow. Yellow. I wonder how many of these 400. Oh, there's a whole pile more over here too. All this is 470. That's a bunch of 470s right here, and all the transistors and all the diodes, the 518s. Yep, a lot of 470s. And this is only one row on this side of the ZIF socket. Woo-wee. I think if you had to design this again, like this board, like a second style of a design, you make this all surface mount. And just get all these parts surface mount soldered on at the factory where they make the PCB. Get them to pre-do it through the ovens. But then I wouldn't have so much fun doing this. So, what we want is to push all these down. So what we're doing here, getting them all in. Okay, I have to take this out for a sec. So what we want here is It's a good thing these legs are pretty flexible. What I'm doing here is pushing them all down, bending the legs slightly to make them all fit and click in place. Yeah, I can feel them actually clicking. Like so. Yeah. You might hear it through the microphone as a... Nope. Maybe not. There's one row. So if we flip it over here, and this is where I had my pokey device out. And what did I do with my pokey device? Here. So what we want to do is like so. Like so. So now we can actually solder this. I'll do a row at a time, basically. Okay. So I had the solder down here. Yep, there it is. Actually, let's move the plastic before I actually melt the plastic. Or it looks like I've been damaging this tip too. If you're wondering, I'm actually not breathing while I'm doing this. I'm holding my breath. Well, mostly holding my breath. Okay, bottom row. And I just wanted to check. Yeah, I didn't bump a button. I better move this mouse out of the way because I might hit something inadvertently, and I don't want to do that. I don't want to have another scenario of yesterday where I screwed up the recording so badly. Yes. So those round displays I picked up and I showed off yesterday, DroneBot just so happened to have a video showing how to use them. And if you don't know about that channel, that guy has such a clean shop, man. I swear you could eat a cake off his desktop. There we go. So that's our first row done, and where's our cutters here? And we need our trash can. Our trash can. Like so. You know, I didn't know if you put diodes down that you would have used square pad holes for orientation purposes. Didn't think that was needed. But I haven't got around to actually building one of my own PCB. I haven't built... That's not quite correct. I haven't actually done a PCB in the modern software. I did them as a kid with tape. Yeah, I know. You put tape on a copper clad board, and then you very carefully let out your traces, and then you did all the soaking. I think if my mom figured out what I was doing, she would be quite annoyed. There we go. How's that? Okay, I think we're ready for the batch number 2. And let me just put my glasses back on so I can actually see. Flip it around. So we're ready for the other row over here. So we were doing yellow that way. Okay, so 470s. Okay. These ones actually might fit better because I put them on the previous notch on the bender. Okay. Yeah, it'd be kind of interesting when I get around to the point where I can actually program this. I think soldering the ZIF socket will be fun. I've never actually, did I? I think I actually have a board here that I did do a ZIF socket breakout. The only trouble around this bench, not the soldering pencil per se, all these monitors generate heat. They have 3 screens, so this corner gets kind of warm in the summertime. It's better in the winter, it's cooler, but not so much in the summertime. Well, technically, we're not even in summer yet. I don't think. Isn't the solstice the marker, June 21st? I'm not sure. I think that is the start of summer in North America. Well, summer in the northern hemisphere. Let us be more accurate here. And if you're a flat earther, you're screwed. Because you won't be able to properly explain how seasons work. A lot of switches. It's a good thing I bought all those switches. 2 more to go in this row. And then we'll press them all down. We'll bend the legs and we'll quickly solder it. Okay. One more. Doink. So let's carefully scoop those off because we're going to need them. And we'll take the board out and we will just carefully, yeah, that's better. Yeah, this is working nicely. I think I'll stick with that one. So what we want to do, of course, is holding all these down. And where's our little thingy here? Bend, 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 bend. There we go. That looks really nice. They're all in the right direction. So let's put it back in our stand here. As I said, if you're going to do this type of shit, this little blue thing is the shit snizzle. Yes. And my soldering and my pencil, a little cleaning on the tip. And let us begin. I have the pencil at now, instead of 3 something, I'm running the pencil at 275. Celsius, that is, by the way. I don't do them foreign, imperial, United States measurements. No, we stick with the magic of metric. Actually, there's a channel called Technologies Connections, and the guy likes to do why you do certain things in certain ways, and he did one on how fast does it take to boil 1 liter of water using different methods. And the methods he showed off were the classic, of course, the gas stove and a kettle on top. Then he showed off a $15 Walmart cheap kettle. And he showed off a more expensive kettle. And then he showed off from his parents, had a ceramic topped stove. I don't think it was an induction stove. It's just it heated up a section of the surface, but it was all flat. You didn't see the heating elements. And then, in theory, I think he had one little tiny induction-based heating little square thing about like that. And you would be really, really surprised which guy failed. And yes, if you guessed gas, you are absolutely correct. Gas is the most inefficient way to boil water. It uses up more kilowatt hours of electricity than you would not believe, and takes longest to do. Yeah, it's really worth watching this episode on this, and you're going, holy crap. Now, there's another trick he showed off. I've done this trick before, not realizing why I was doing the trick, but I have heated, water in my kettle and then put it into the pot and then continued on cooking because I knew it took forever and slow to boil water on a stove. Even though, let's say you had a pot with like 3 liters of water in it and you're making pasta. Yeah. But this was a really cool episode on this. Of course, he had to get the snarky remark in for the Europeans who go, ha ha, we have faster boiling water. Yes, it's true. If you do not know this already, boiling water in the EU or the UK is quicker because of the 220, 230 volts. It's not because technically the higher voltage, it's just they can actually apply more power to the circuit. More power means faster cook. So since I was doing that, I think I will, for the horizontal ones like this, 470s over here, I will do yellow to the left. I liked his episodes on the history of videos, like where video discs came from. Do you know they actually pressed video into vinyl initially? They actually had a technique of storing a video signal for like a movie in a vinyl medium. That I didn't know about. That was cool. Okay, one more yellow. 2 more got to go. 470. 470. Where's more 470s? Oh, right here. 470, 470. And then here's a whole row of 470s, and here's a whole row of 470s. All around those transistors. So let's slide this out and do our press, 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 press. There we go. And our little bar here. And we add that back into here. There we go. Some solder. Clean our tip a little bit. Yep, even at 275, I'm flowing pretty good. And who knows, I might save some tips. There we go. Just flex all these up. One more. There it is. Yeah, even without my glasses, looking at this, this stuff is pretty darn fine. Okay. I know some people who save all these little clipped off leads for jumper cables and other silly things. I don't. I think I end up with a whole ton of crap wire. No use for the sake of hoarding it. There we go. There we go. Flip it around again. So that's another row done. So I guess we start between the transistors. I'm running out of resistors actually. There's another one. And there's another one. Okay. Yellow to the left. So there was a 470 here. Okay, where else? 10Ks along here. 10K, 4K, 7. 1K, 4K, 7, 4K, 7, 10K, 4K, 10K, 4K, 1K, 4K, 1K, 4K. How about over here? 10K, 4K, 470 right here. There's one there. 4K, 7, 1K here. 470s all over here. Between these transistors. Uh, 470. Wonder why you needed so many transistors for doing all this. I find it kind of interesting how he did this circuit. 470. And I think that's my last one. Yeah, my last one on the table. I'm out of them. I have to do some more now. Okay, so glasses. So I have another batch. I think these are the right ones. Let me just double check on this. Could be these ones. Yellow, purple, black, black, brown. Yellow, purple, black, black, brown. Yeah, these are the right ones. Okay, so that's these. And these guys here can go into the trash can over there. Okay, so where's our bendy dice? Okay, here. And we're using the second one in this time. So we bend some more. I don't know why. Stupid piece of plastic, and this thing is atrociously expensive. To get one of these things off AliExpress, I think was like $20 for a piece of plastic. Yeah. Funny thing, I can get a ESP32 microcontroller board, right? All the stuff on it, everything on it. I can get like 3 of those boards for $20, 4 of them, right? But this piece of plastic, no. And I hunted around for that one. I wanted one. Plenty of people selling it, but everyone was charging an arm and a leg. Okay, those are all the 470s there. Okay. Now just looking on this side, these are all diodes. 10Ks here. 1K here. Why did he say 54 of them? I can't find 54 470s. 4K 70, 1K. DON. But don't see any more 470s anywhere on the board. 474 for cap. Those are C's. Ah, 470. I found one. Right here. R82. 470. I do not see any more 470s in here. Why did he say 50? Maybe the power board. Maybe that little green board that goes on here, up there, uses a couple of 470s. So let's slide this out. And I am, there we go. I was just watching a video from Linus, and he was doing another one of those petabyte servers. It's like, come on, give me one. I want one. I'm sure I could find a use for putting, too many petabytes around the apartment. How else do we all store things? Right? Okay, kind of do this if I feel. Okay, so now I'm on this side. So this side, this side, this side. There we go. This will be a fun solder job here. Okay, there we go. Okay, where's my solder? Here it is. Even blind, I can find it. Okay. This is where the fun part begins. Getting all this solder in all these legs. And I might have to cut legs prematurely just to get in. Oops. Wow, this is tricky. So Linus did his classical thing on the video today. He dropped the hard drive. He literally had one sitting casually in a server wrapper bag on the counter, and then he went and dragged the bag away to put it away, and the drive fell off the table and went a bang on the floor. Poor Jake, he was like, heart attack. And these weren't your small little hard drives. These were 20 terabyte Seagates. So where's our trash bag again? So I think we got all the 470s. We'll have to have another look just to make sure. Some might say I should edit this section out, but sorry. I find it relaxing watching stuff like this, personally. I don't like the zoom ahead, and I watched this one guy assemble this, and he zoomed ahead through all this stuff, and it's like, would have liked to have seen exactly how his style was and everything for doing this. You know, I might actually have to get a new side cutters out. This one's starting to get a little gnarly for cutting. One more. There we go. Okay, so let's have a look at the board. Uh-oh. I have a couple of raised caps here. They didn't go all the way down. That's okay. We can fix. This one here. There we go. And this one here. There we go. This one here. There we go. Down, 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 down. Otherwise, I think all the others are good. Yep. And I have a couple of legs that are a little high now. I guess for that. There we go. Fixed. Okay, so we have our resistors for 470 ohm. Okay, next set of resistors. Come on in. You can't even see it actually. There we go. So let's see our next batch of resistors. 4K7s. We have a bunch of these. So let us snip and fold. Yeah, if you're wondering, when I take my glasses off, everything's like magnified. I can wear the magnifiers on and keep the glasses on, but they're pretty heavy and hard on the ears. I only do it when I really need to do it. For this sort of case, I just continue doing this style. Okay, so that goes in the trash can. And then leg folding. And you're probably saying, William, did you measure this resistor to make sure it was 4K7? Yeah, oh, by the way, in North America, we will write 4.7K. And in Europe, they will write 4K7. I prefer the European method for labeling a resistor. Use the K in the decimal place spot, or the M. So you have 1M2, for example, it's 1.2 megohms. I do like that style. So all my sorting of my resistors and stuff are all done that technique. Okay, so multimeter ends on ohms. And pick a resistor. I can barely see them. And let us find out. 468, 4.7. Good enough for government work. Maybe not your government, but our government. Okie dokie. So, there's a bunch of spots in here that have 4K7s in them. So let's find them. That's all diodes down here. But in here, they're 4K7. Right there. Another 4K7 there. And another 4K7 up there. Okay, another 4K7 there. Right beside a 10K. Another one beside a 10K right here. And then we have another one right there. Okay. Okay, so 4.7 right there by the transistor over here. Okay, what else? Upstairs, there's one up here. So let's get one up here. There's a 4.7 and a 10K up here. There's another 4.7 up here. And there should be one more according to this. Unless I get one extra. 1K, 10K, 10K, 10, 4.7, 1K, 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 10K, 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 1K, 4K7 right there. And CC, D. That's the other thing I haven't got. I haven't got a polyfuse. CC, C, 1 megohm, C, jumper blocks. Okay, so I think I got them all. Used them all up. So let us push them all down. Like so. Okay. And then this batch. Ow. No, that was that resistor here. I felt that. That. No, that will stay that way. It's this one right here. And this one right here. And then these two right here. So, there we go. Okay, let's put it in. We solder this batch. So we got the two here. Two here. Did I get them all? It looks like it. Okay, so we got these ones. Oh, that one really rose. That's not a good one. That one is here. And the other side, better. This one's a little off. There we go. That is flush. That's better. So, where's my trash can again? Here we go. In the trash. Sorry if my head's in the way. I need to look at the... Oops, I missed a hole. I just spotted it. It's okay, I'll get that one in a sec. There we go. Okay, so we missed one solder point. That was that one right there. There we go. Did it float it? Nope. Good. Okay, so that's all the 470s, 4K7s. So there's another big batch in here. This one right here. And these are 10K. 100 red, brown, I think it is. These are definitely ones you want to measure out because it starts with a brown and ends with a brown. So tolerances on this, like all these blue ones, they're like I think 1/8 of a watt resistors, and they run 1 or 2% tolerance, like something like that. So they're not your usual gold silver tolerance bands on the end, so you can't tell which end is really which end. They're not easily done. So this is definitely a case of the multimeter. We need to make sure that we actually have 10K here. There, zero out the multimeter. 9.6, yeah, this is 10K. I do like the auto ranging on the multimeter for the ohms on here. So now we have to do a leg bending again. So we have a bunch of 10Ks to place. By the way, when I look at these resistors, there's the blur on the table at the moment. I'm doing it by feel, figuring out where there's a resistor under my fingers. Here's another. And some more. I could brighten the light a little bit, but that'll make a lot of glare off the white. What the heck, why not? Not that one. Oh, now I screwed things up, didn't I? Oh, come on. Get out of me. I dropped something on the floor. Oh, yeah, the pokey device. There. There. Now, let's see. The middle one? Yeah, there. It's a little brighter. But you have to watch out on this camera. It has a tendency to cause white to really reflect. Okay. No, where was I? Oh yeah, feeling some more resistors over here. A little more. Actually, I'm looking forward to testing this out. Okay, there's one more there. Okay, William. The leg slipped under a leg and then became a spring. Okay, so any more down there? Nope. So we need 10Ks. So well, there is a fat brown on this one now. Oh, interesting. Thin brown and fat brown. Well, let's put the thin brown down toward the south here. Oh, that was funky. These holes are slightly more apart than the other holes were. Just slightly. $10K, $10K, $10K. We'll get this strip of 10K. Uh, 10K. Okay. Now we have some other 10Ks all over the place in here. So there's a 10K right there. Another 10K higher up. Another one right there. The old matching pairs of them, apparently. Okay, so we got a couple more. 1K. 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 10K up here. Right here. Up in this land. Okay, there's still one more here. So, I don't know. Some of these resistors, I took 2 instead of 1. Just one extra just in case. But 220. 474. All the diodes. 1K. Ah, there's a 10K. Right there. Like so. So this one here. And these two. No, this one. And then this one. This one. Right here. Then we have all, whoops, I just dropped one out of here. So that was thin brown this way into this one. Gotta be careful of these edge ones here. Okay, so that, and then this, and then this one, and then this one, and then this one. Okay, actually let's turn this around because it's more soldering to my end than is the other end. Okay. Yeah, I'm on the verge of changing the tip on this pencil at the moment because this one's got a banged up tip.
Okay. Now, of course, if we were assembling this probably in Europe, we'd be using lead-free solder. So this board is not RoHS compliant anymore. There is lead involved.
Toxic material. Okay, trash can.
Let's do these guys first.
Whoops, we forgot a whole resistor way back there. Here we go.
Oh, there's a leg that was a bit on the long side. Okay, one leg more.
Okay, so those are the 10K resistors done.
Turn it around, put it back in here. What's my next big batch of resistors?
I think I only have one big batch left, and that's this batch here, which is 1K. Yep, 1K. So clip them out. Now, according to the BOM, I believe I need 9. Whoops. 9 of them. Yeah, I definitely have to change the tweezers. They're not clipping anymore. Don't worry, I have like 7 pairs of these things. I assumed you were worried. Okay, so those are those. Okay, our bendy tool. So there's a bunch of 1Ks to do. It'll look very blue resistory. If I had to do these in bigger quarter watts, it would all be beige. Blues tend to be eighths, beige and higher tend to be quarters and halves. I don't think anywhere on there I have a resistor that's like 1 watt or anything. He didn't specify that on the BOM, so. And I looked at the picture of the thing, and I didn't see any high wattage resistors anywhere on the board. Okay.
So where do we put the 1Ks? Thin to thick? Okay, so 1K right here. And I'm doing thin to thick 1K right here. There's another 1K. Okay, there's a 1K right here.
I hear there's a whole study on when you make these boards
that you learn how to minimize parts, or you redesign the circuit so they use very same parts. Like if you had to do resistors on here, if you could populate this whole board with the same resistor, it cuts the cost on everything. Okay, so what do we have up here? 1K right there. what do we have here? C, JP. Oh, another 1K right there. R58. As I said, I think there was 9 total. So let us just double check here. CCC, Ds, transistors, diode, transistors, relays, transistors, LEDs, switches, diodes. CCC, this one is a 220 ohm resistor, and this is a C.
So this is the extra one, the 9. Okay. Now, we'll begin over here. And then this one. And this one. And how about this one? And then this one. Okay, this one right here. Okay, this one right here. I think they're all done. Okay, so flip it over. I do have a little bin I just collect miscellaneous parts in. Okay, so let's put that over there.
Okay. Okay. Didn't miss any holes. Okay. That's the last big batch of resistors. Trash can. And okay. Okay. Now, one more. Nope, 3 more. Okay. So that is another set of resistors. So now we have a couple of miscellaneous ones. So let's see if we can find them. I have 3 sets here. So another 4, and I think this is the 470. I think I only need one of them. 470. Yeah, I think this is 470. 1 meg ohm is up here. The 220 over here. CCC. Diodes. It's kind of like a puzzle. You got to find where all they are. C10. 1 meg ohm. So I just need the meter. I need to make sure what I actually have in my hand is 470. 4.6, 4.7 ohms.
I'm going to need this. So it's not 470, it's 4.7.
I thought I saw 4.7 somewhere around here. 220. CCC. All these D's. A D here. D there. A C there. A C there. A Q. Interesting. I'm not finding it. So where did it go?
Well, there's definitely 1 megohm, so let's just put this aside for a sec. So which one is this one? Which one are you?
220.
So this is the 220 one. As I said, I had a spares. I got some spares just in case I dropped one or something. So thin to thick.
And I know the 220 was up here. Right there. So that's 220.
And I bet you this one's the 1 megohm. Yep, 1 megohm. And again, I had a spare, so. And
1 megohm was right there. Okay.
that leaves that 4.7. Now I'm just going to check the bomb to make sure. It's got a number on it, so so according to this, 470, 4K7, 4R57. R57. So what we're looking for here is R57.
So Q's, B's, L's, D's, diodes, these are all 10K, 10K, 10K. That one was 470. They list R. Where is R? Well, okay, so R62 is over here.
So R38. So this was R17, 18, 19, 20, 15, 32, 21, 25, 11. So more over to this side.
CCC. C. C. Crystal. Cap. 10K potentiometer for the dimmer for the LCD. C10 right there. Is it on this board? On this revision? They didn't put anything on the back side, did they? No, they didn't. So where did it go?
Where is R57? 4.7 ohms, right axial, DIN 027. Number 10. So it's supposed to be on here somewhere. So where is it? R74, 73, R69, R65, R59. Right there's 59. So that's R59 right there. This one here is R62. Has to be in this area somewhere. Oh, and I just found a risen 470 R17. So where the heck is R59? Well, one thing I haven't checked yet, let's just slide this back in here, is the little daughter board. Let me just find it in the bin. There is that little daughter board right here. So this guy right here. Maybe it's on here. So here is that USB thing and this board. I haven't even taken it out of this pack. Okay. So what do we got in here? D1, R4, C's. Nope, not on this one. Okay, so it's not on that. But according to the bomb, it's R57. Okay, let us reverse down to the schematic and see if we can find where it hangs off of. No, those are all the add-on boards. So somewhere on this board is an R57, but I can't find it. I can find diodes, capacitor, buzzer, cap, crystal, 1 meg ohm resistor. That's the R75 right there. They talked about in the bomb. MOSFET. Wow, you can even have a surface mount version here. C, D, L. Polyfuse along the side here. I cannot find an R57. R78, Maybe I should have done the individual ones first. 10K, 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 10K. That's all 10K. 470s. 470s. 4K7, 1K, 4K7, 1K, 4K7, 1K. 4K7, 4K7, 10K, 4K7, 10K. 4K7, 10K, 1K, 4K7, 470, 470, 470, 470, 470, 470, 470, 1K. Wow. For the life of me, I cannot find a 470. And all these are all 470s. Yep. Yeah, that's kind of funky. I cannot find a that no. I can find the capacitors and the diodes. But it should be past this one right here. This is R59. R61, R60, R59. And what we're looking for is R57, if I remember correctly. R57? Yeah, R57. So 59 is right here. And 53 is here. So where is R54, 55, 56, 57? Yeah, so where is R50? That's 59. We have to have 557. So where's the R's from that? 70s, 20s, R24, R32, 33, 34, 35, 36, 37. 17, 18, 19. 4K7, R1K, R58, right here is 58. Uh-oh. Right, found it, 57. So what did I just attach there? I think I attached the wrong resistor right here. Nope, 4.7. I better put my glasses on to check that. So, right here, 4.7. Did they put 4.7K? Oops. Yeah, I put 4.7K, not 4.7 ohms. So this guy right here is the wrong resistor. Come on. There we go. There we go. There we go. Let's see. So now we have R57 4.7. So that should be this guy right here. Where's my ends? 4.7 ohms, not 4.7k ohms. Yep, 4.7 ohms. So there's our 4.7 ohm one that's supposed to be. So that was an incorrect resistor. And this one here. Okay, that's much better. It would be nice if I had actually a diagram of where all the parts were in like a grid. I've seen that done before on some. If you're not wondering why I did the knocky thing, liquid soldered and you tap the board and it falls out. Otherwise, I'd get a brass wick and suction and stuff like that to get it off.
So let's do U. And redo U.
There we go. Trash can.
Now we have the correct 4.7 in there. So we should be done resistors. Luckily there's hardly not that many caps to do.
Okay. So that is Mr. Resistor Land.
So we have these caps here. So the first four we have here
are little discs. They're 104s. So we need to find the 104s right here. 104. If you're wondering, it's 10 nanofarads, I think it is. The 10 is the 10 and the 4 is how many zeros you got. Okay, so those are 104s. Now there's supposed to be some more 104s. 22s. There's a 104 up there. Right here. I'm kind of staring through one eye to one side of the board and one eye to the other side of the board. Okay. Now we need another 104. There should be 4 of them. 104 right here. There's the barrel jack 104. Suppose it depends how you do power in this section, but it was, you could put it in, but it was actually, I think this was listed as an optional part. Let us face it this way. So like so. Okay. Okay.
104s.
Okay. Trash and clip. Okay, done. Okay, so our caps are in.
Those ones. Now we have another pair here. our next set, and more disc, and they are 22s. And you can guess right here is two 22s. This, I believe, has to deal with the LCD display. There we go. Okay. Done. Trash. Okay, so our next capacitor. Let's pull the power transistor down too, and these guys. So next one we have here is these guys, 224. So where are 224s? Okay, so, there's a 224 right there. Where else is a 224? 474. 104. I missed a 104. 104, 104, 1, 2, 3, 4. I need a 104. I'm missing a 104. I thought I had. They didn't list that many of them. 104s. 4 of them. Oh, they gave the red one, C3 2. Yes, optional. Okay, I put the optional in. Okay, whatever. I will fix that. 474. Where's the other 474? Right here. Well, I can't get it in the hole. Come on, there we go. So what we have over here is bendy leg. This is like old school ceramic, and this is like really new school ceramic. Kind of like the newer ones. Kind of like a dipped thing. So I'm going to go up to the rack at the top and get another capacitor. Where did the other one go? Oh, right here. So I have a whole container up there. I have to take this off. Okay. So this is my capacitor connection. So we were after 104s. 104 discs, I think. Actually, wrong connector. That's okay. We need the other one. That is this one. 104s, right there. So 104. Ta-da. These are all my ceramic collection. So I simply went to Staples and got a bunch of those little envelopes like that. And a friend of mine got me these white boxes. They used them at his company. And
Ta-da. Okay. So, 104. So, we turn this around and find the missing 104. The one I missed. 104, right there. Okay. There we go. Okay, 104 right here. There we go. So, now there was a power transistor here. L7805. And I think this is what this one is. It's just a little hard to read the labeling. L7805. This is where I kind of need my little magnifying glass to read these. Where did I put that? Shouldn't it be in here? Yes, it is. It's just buried. There we go. Yeah, L7805CV. So they want this like so, and then bent over like so. So the way I would do this is like so, and like so. The big metal tab is the heatsink. Oh, that's just the multimeter telling me I should turn it off. Okay, you whiner. I'll turn you off. And I got these. And this. And this one. And this one. And then these guys. Like so. Okay. We'll need a bolt or something to fasten through there, but so far so good. Okay, so now we had one of these. So we want positive to the open side, negative to, and this is 100 microfarad, 25 volts. Should be enough. Okay, so put it in here. We do that one. Okay. And I hope I didn't knock anything. Nope. Okay. Okay, so that is our one cap. I wonder if they want us to lay it flat down. That is a good question. I might have to actually pull and put another one in and fold it over. Because there's an LCD going up here on these. Is it these post holes? And then there's a board that goes on here, so that's that one. Like so. So there's a post hole here and a post hole. There's two post holes here. I wonder. Okay. Okay, so we have to find out. Okay, so we have LEDs. So power, VCC, and there should be one more LED. Where are you? There's VCC and power. VCC and power. Where's the other LED? Are you on this side and this side? I am not seeing it. Oh, D46 active. Right, so I decided I was going to use a green one. And of course, I never remember the legs on this. So long legs is positive and short legs is negative. Something like that. So I pull out my magic ruler here, which has the Adafruit thing on the back and which has an LED. So long lead is positive. And square pad is negative. So long lead is positive. So I was going to put the green one in here, like so. And I was going to put the red one for VCC. Like so. And I was going to put the blue one for power. I like blue. Like so. So let us solder these in. Now we are going to go make sure these LEDs are kind of flush. And they look actually pretty good. No, this one's a little high. There we go. And this one. And then this one. They're good. Okay, so we've got our LEDs. Ouch. I just poked myself. These legs are more hurtful than the resistor legs are. They're stiffer wires. And that one. And that one. Okay, so we've got our LEDs, we've got our caps, and we've got a resistor. We've got one power transistor installed. That leaves a lot of diodes. And over here, there is a connector over here. Let's just slide this board so it's on the narrow side. So there is this thing right here. This is that USB thing. Now I'm not sure how they would have me plug this in. It doesn't look like it's horizontal to the edge of the thing. Oh, it looks surface mounty. Okay. Of course, this thing is me-proof. I can't get into it. Okay, so I'm going to just have to cut the tape. There we go. There we go. So what do we got here? So they would have this.
somewhere around here. I think it's this one right here.
So let's look at the bomb. I believe it is what they call J2. Okay, so let's find J2 in here. If you're wondering, this is what I'm looking at. So we're looking for J2 in here. Y switches J1, J2, USB. Yeah, pin header, blah, blah, blah. Okay. So,
interesting. Technically, this is not the right one for this. I mean, yes, they have it in here like so.
But these legs are bent that way. Where's my needle nose? I might break this jack, so let's just find out. It's supposed to be like this.
I mean, it's USB power is what we're talking about here. I believe.
I don't think it's data. Doesn't seem right. There's only 2 wires. There should be 4 for USB. Oh, this is so finicky fine. Oh, come on. Yeah, that's what I thought. Frickin' off. Well, you know, I bought that bag of ends. Where did I put them? So I stuck the bag of USB stuff with... Didn't put it in the car one. Just a sec, I have to go hunting around. Aside, set of tips. What did I do with it? What did I do with it? Here. Well, we have now to dip into our collection of USBs. This was crap. It's the wrong one. So what we have here is we need this, but we need the one, a more correct one. I need to take my glasses off for this. No. 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 Nope. Horizontal surface mount. We need a more pure pin version. Okay, so this is right idea, wrong one. Nope. Don't think so. Nope. Definitely nope. Nope. Uh-huh. Maybe. No.
Nope. 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 It's this one. Nope. So we're after the one like this. Nope. 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 This would be really bad if I have a whole bunch of these and none of them have the right pieces on them. Nope. 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 No, that's a USB-C. No, that is a... Nope. Nope. That's 2 pins down. Nope. 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 We're running out of choices here. This is crap. All these varieties and they just don't match that. It's 5 pins. Longer pins. There's no guarantee that the pins match out. I mean, on this one, they are doing 2 pins. They're doing the 2 outer pins, is what they're doing. So that's short pin. That's short pin. That's a long pin. That's a short pin. That's a long pin. And that's a short pin. Well, let's see what happens on this one. Okay, so the key here is, does this bottom holes match? Do we still get the same spacing? Nope, not on this one. So the spacing on this bottom holes are too close together. So the spacing on that is too close. The spacing on that is far apart. The spacing on this they're far apart, but I need the longer pins. I think that's, yeah, that's too close. Longer pins, but farther apart. Let's try this one. Okay, so let's try this. So farther apart pins. Yes. But well, we could get rid of the pins and the tail pins. So let's bastard this connector a little bit. Okay, so that's that. Those little legs are off. You know, these guys just don't stand out enough. We have a problem. I have a botched USB connector and I can't find the right one. I need this silver one with the really long legs on it. And I don't have that here. I have lots of short-legged ones. And a lot of these, they're all surface mount. Yeah, okay. Well, we have a problem. I have to go buying a part here. Of all these USB things, they're all technically wrong. Now, I got some containers. Let me just a sec. I'm going to be right back. I did want some little pocket containers to store things like this. So I could store these things. Like so. So we need this one, but we need the version with the legs down. Why on earth did you do a through-hole design when the USB port should be in a surface mount? That is just dumb. Okay, so we're kind of stuck. I'm going to actually call it, but I have to do some part research and see if I can replace this USB. What the hell is J1B2? J1B2. Is it in here? J1B1, USB BOST, USB horizontal. J2 is also USB. So are you telling me that you little... you really wanted this on there? Well, even that is not right. So we got that one. USB micro. Let's just go see if we can find that connector. This is not the right one for the thing. 3. Two pull. Copy and... So I can get them from DigiKey. But that doesn't match this one, does it? No, it doesn't match this. This is not the right one. See, there's 4 legs in the picture. Let's go find the physical spec.
Drawing datasheet. Yeah, see? 4 connector. This is a 2 connector one with the things in the middle. But notice that this is this, and this matches. So this is the pinning layout for J1B2, and J2 is the one with the center, but it has the pins down. So this is not that. I wonder if DigiKey has this. And they must have a zillion of these. Control C, DigiKey, Control V. Well, definitely going to have to do some hunting here to figure out this one. This is something how I find, new tab to the right, paste. Not the cable, but the PCB. Yeah, this right here. Yeah, see, surface mount tech. USB micro connectors, DigiKey. Okay, so there's our second pole in the center. Is that pins down or pins across? Let's open this guy up here. Well, it's definitely legs down. That's the one I just had. And I clipped these off. These legs are too short. Okay. Well, you know what I'll be doing. I think next batch we'll do the diodes and stuff, but I got to work on this. Now, there's also, I guess there's 3 different, I think the idea along here is there's 3 different power connectors. So I think I've got the barrel jack one here. Just a sec. The barrel jack right here. I think I got this one. Even if I can't do this guy, this guy, this guy. So we'll find out. It might be they'll never install this onto here and we end up using a barrel jack. I think that's actually more robust than these two here. Because all they're doing with the USB is feeding power. So this is not quite the right one for this. If I was to plan this PCB out here, this shit here, these 2 holes, they wouldn't be holes. They would be surface pads going like these guys right here. And so that since they're out horizontally, then they would line up and you would put it I would shift this whole thing. Right, a little bit. Maybe I'll shift the USB connector for it. Nah, I can't even do that. But you get the idea. I mean, I don't think that was a good design on his part. But that's where it sits at the moment. So this is where we'll cut it at the moment. And next pass at this, we'll do all the diodes and the transistors. I still have to order this chip. I don't think I have this in my collection. Not that guy. And then we have to build this board here. And then put the display section on. The programming header on. The switches on. Well, there's a bunch of work to do. So I will let you go for the afternoon or evening or morning, depending where you are.